All right, we're ready to start difference quotients. Difference quotients, when you apply the limit to them, gives you something called the slope of the tangent line in calculus. And it's one of the major ideas in calculus is to find the slope of a tangent line to a curve, like a parabola or a cubic that you put a point on, and you can draw this nice linear tangent line and you would know what the slope is. That was one of the issues that they investigated when they created calculus. But in algebra, you studied slope, rate of change, and you had one of these formulas. Maybe your teachers told you y2 minus y1 over x2 minus x1, or f of b minus f of a over b minus a using function notation. The difference quotient is nothing but slope or rate of change. Only we're going to call the a, or x1, x, and the b, or x2, x plus h. So then the formula becomes f of x plus h minus f of x all over x plus h minus x. But the x's cancel, and so you end up with this cute formula that is nothing more than the formula for slope, where h is one of those numbers that's really close. So, you're doing the slope between 2 and 2.00000000001. Okay. We must master 4 types of difference quotients, and these should all take you back to worksheets on limits 5, 6, 7, 8, and 10. Difference quotient 1 is the easy one. We're just dealing with polynomials. So I give you the function f of x equals 3. Please put the brain back in your brain and remember that this is called the constant function, which is graphed as a horizontal line. The key is it's the constant function. It's a constant. It never changes. So your y value is always 3 no matter what your stinking x is. So f of x is equal to 3, and I substitute in something else, x plus h. It's still 3. I substitute into my formula, which I always write. The difference quotient is f of x plus h minus f of x over h. And 3 minus 3 is 0, and 0 over h is 0. Notice, I know you're shocked, but this is the slope of a horizontal line, and I told you that's where we're heading. You ask, must I show all 4 steps? And the answer is yes, you must. So sorry, folks. You always want to do less. I show you the minimum, or I mention, oh, you don't need to show that. So now we have an oblique line, and we know that its slope is 7, and let's show that it's true. Now f of x is equal to 7 minus x. It's a linear function, that's its name, but its graph is an oblique line. So given f of x is equal to 7x minus 3, I'm going to substitute x plus h for x, and I get 7x plus 7h. Notice when we're linear, this matches. So a 7x yields a 7h every time. So I come down to my difference quotient, f of x plus h minus f of x over h. I substitute what is playing my f of x plus h, 7x plus 7h minus 3, and I'm going to subtract 7x minus 3. Now notice what happens. I don't distribute. 7x minus 7x, they cancel. Negative 3 minus a negative 3, they cancel. And so all you're left with is 7h over h, which is 7. And again, we know this already. The difference quotient is the slope. It's 7. Yay. We'll do one more linear one before we move into higher degree polynomials. We know this answer should be negative 8. Again, we have a linear function whose graph is in an oblique line. Here's our function, f of x equals negative 4 minus 8x. I'm going to substitute x plus h there. So it's over here. Notice when I distribute, not only did I get a negative 8x, I get a negative 8h. So substituting into my difference quotient, f of x plus h minus f of x, I have my negative 4 minus 8x minus h and my negative 4 minus x. Notice a negative 4 minus a negative 4, they're gone. A negative 8 minus a negative 8x, they're gone, and I'm simply left with I'm simply left with negative 8h over 8, which is negative 8, which is the slope, the familiar slope for the line that we're used to. So now, moseying on into the next room, we're now going to talk about higher degree polynomials, but before we get there, sadly, some of you have trouble with expansion. We're going to remind you of Pascal's triangle to help you through your misery. So notice the top one means x plus h to the 0. We wrote it earlier as x plus y and a plus b and f plus l and all those cute things. But you're always going to be using x plus h now, so we're just plugging in x plus h instead of f plus l. And to the 0 power is 1. X plus h to the first gives you the 1x, 1h. X plus h quantity squared is 1x squared plus 2xh plus h squared. You should be familiar with those. When I cube, my magic numbers are 1, 3, 3, 1. And as the x's go down, the h's go up. So x plus h cubed becomes 1x cubed plus 3x squared plus 3xh squared plus 1h cubed. And for fun, one more. Pascal's triangle, remember I added 1 and 3 and got 4, 3 and 3 and got 6, 3 and 1 and got 4. Every other row is in between. So x plus h to the fourth is 1x to the fourth plus 4x cubed h plus 6x squared h squared plus 4xh cubed plus 1h to the fourth. Now, for those of you that really buy into pattern, what if there's a constant there? It's a constant time. All that you do to what we have above is add a c. So if you're multiplying by 2, you just make sure that you do what's above times 2. So the 1, the 4, the 6, the 4, the 1 would become a 2, an 8, a 12, an 8, and a 2. Yes, that's it, folks. Isn't structure and repeated reasoning beautiful? It rocks for us mathematicians. Now we're ready for higher degree polys. These will always have an H in the answer because of the circumstances this year. We're going to be about a week short of finishing what I usually do. We will not get to evaluating the limit of our difference quotient as H goes to 0. It is one of the first of the 3 major ideas that I told you earlier applied in calculus. So this one is not linear, it's not constant, so I cannot actually find a slope. This bothered mathematicians for years, let me tell you. It took lots of years to create calculus. Newton did it during the plague. Leibniz was doing it in Germany at the same time when the bubonic plague was going on. So f of x equals x squared minus 5x is a quadratic function whose graph is a parabola. So here is my quantity squared, x squared minus 5x. I substitute my x plus h's in. Notice, what's the rule for this? Square the first, square the last, first times last times 2. Whenever you see quantity squared, this will always be x squared plus 2x plus h squared. You don't need to square it out every time, folks. That's it. Notice the h coefficient matches the x, negative 5h. I'm doing my difference quotient, f of x plus h minus f of x all over h. I substitute in my f of x plus h. I substitute in my f of x. And just as before, it doesn't have an h. This x squared is killed. This negative 5x is killed by this one because I'm adding. And the only thing left has h's in it. And now when you're dividing by h, you just taketh away an h from each term. Now this is what your answer will look like. If we had one more week, you would have done this. You would have simply said, oh, the limit is h goes to 0. And wherever you see an h, it disappears, and now you have a formula. So if I wanted to know what's the slope when x is equal to 1, at the coordinate 1, I would know my slope was -3. What's the slope of this graph at 0? Well, at 0, the slope would be -5. What's the slope of this parabola at -1? Well, at -1, it would be -7. And what about at 10? When x is 10, the slope is 20 minus 5 is 15. Again, we won't be doing that. Sorry, we don't have time. So now we're going to look at example 5, and example 5 just has more going on with it. It's another quadratic. Notice I'm going to substitute my x plus h's. Notice when I distribute, by the way, if you want to use the pattern like your teacher, you're going to say, oh, I know you're x squared, so you're -7x squared. You're 2xh, so I know you're -14xh. You're h squared, so I know you're h squared, and I don't have to show that middle step. I can just show the first and the second one. So doing my difference quotient, f of x plus h minus f of x over h, I substitute the f of x plus h, I substitute the f of x, and notice, that wasn't supposed to have an x there, sorry. This 6 minus 6 is 0, -5x, and a positive 5x minus my 5x is going to be 0. And over here, -7x squared minus -7x squared is 0. The only thing left has h's. I taketh away an h. Here's my answer. If I were doing the limit, this would represent the slope formula. I could plug in any x and find the slope on my curve for the tangent line I would draw. Another problem, this is a cubic. I didn't say this is a cubic function and the graph is a cubic. I mean, it seems like very redundant. So I'm just coming into the substitute phase. Now notice I know this one. I've told you the numbers are 1, 3, 3, 1. The fact I see a 2, I know the numbers are 2, 6, 6, 2. So I do not have to show step 2. I can go from 1 down to the last step if that suits you. So my difference quotient is f of x plus h minus f of x all over h. I substitute my f of x plus h. I substitute my f of x. Now I want to combine my terms. A 2x cubed kills a 2x cubed. I forgot to put in my -3. Oh, hold on. -3. -3 kills -3. Little righto there. So I'm going to take away an h from each of them. And there's my formula. Had I been trying to find the actual slope and done the limit, notice the h stuff would disappear. A very simple formula. Example 7, I do a 4th degree, a quartic, which is going to give me a quartic graph. And so I just do the substituting. And again, notice, if I see the -2, I know my numbers are 1, 4, 6, 4, 1. So I knew my numbers were simply -2, -8, -12, -8, -2. So you can go from step 1 down to there if you like. So f of x plus h minus f of x all over h is my difference quotient. I substitute. Sorry, I'll go in so you can see I've substituted everything that I was supposed to substitute. And so now, what's going to happen? Over here, this 1 is killed. These two kill each other. This -x and that -x kill each other. I have a 2x, -2x to the 4th. It's gone. And so now my next step just has everything that has an h in it. And now I need to reduce it by an h, and so I'm down to here, and notice this one, and this one would disappear, and that would be my formula for finding slope had we gotten that far. But you're just going to stop here. You're not going to do the limits. Now, all of these examples are in the notes that will be attached when you start this, that are in the packet. If you picked it up from the bus or you go into Bloom and pick it up, it will be in the difference quotient packet.